Okay, so comparing functions, notes 14. Okay, so remember, when we get a table, we want to see if there's a pattern. So nicely, on the x side, -3, -2, -1, it's going by 1. On the y side, what's it going by? Looks like it's going by, from 1 to the next, right, is by +4. If I add 4 to that, I get -7. If I add 4 to -7, add 4, I get -3. Add 4 to the -3, I get 1. Add 4 here, I get 5. Add 4 here, I get 9, and so on and so on. So the change in y, so we think of it this way, change in y over change in x, the change in y is 4, and the change in x is 1. So the slope simply here is 4. Do we have the b, the y-intercept? Remember, the b is at when x is 0. X is 0, so this is our b. Okay, so our equation here is going to be y equals, put our slope, 4x, and then it crosses at 1. So how do I graph it on this graph down below? I could take every one of these points and graph it the long way, or I could just use this. I start at 1, is my y-intercept is at 0, 1, that's one of the points, right? And my slope is 4, which is technically 4 over 1, right? So I could rise 4, 1, 2, 3, 4, and run 1. Look at that point. That point is 1 what? 1, 5. Isn't that the point right there? 1, 5. All of these points would be on this graph, but if this graph was large enough. Let's do a negative, -2, 7, or -1, 3. So if I go here, -1, 1, 2, 3. And that's the same slope. Rise over run, it would be run 1. In that case, down 4, because we went left. Hence, it's a positive slope, so the line is going uphill. Perfect. Nice. Very easy. Let's see the next one. -3, -2, -1, 0. 1. Beautiful. Going up by 1, right? Plus 1 on that side. 2 to 0. Oh, then to -2. Then to -4. Then to -6. Then to -8. Then to -10. Interesting. So technically I'm doing 2 minus 2 makes 0. 0 minus 2 makes -2. -2 and another -2 makes -4. So this side is by -2. Are we good? We see how the difference on the way this pattern is consisting here. So if I do my change in y over my change in x, the top is by -2 over 1. So m here, the slope is -2. Okay? Do we have the 0 in the x column? We do! We win the lottery. This is your b. Okay? The b crosses at -4. So my equation is going to be y equals, my slope is -2x, and my b is -4. Take this down to the graph. Let's just find 0, -4. 0, -4 is, -4 is down the bottom. 1, 2, 3. 0, -4 is right there. Right down in the bottom. 0, -4. And my slope tells me is my m is technically rise over run. I can go down 2 and run 1. Okay? So if I want to go backwards, I go up 2 and back 1 to get the pattern to keep going. Up 2, back 1. So let's see if these numbers are there. -2, 0, that's there. Let's do -3, up 2. Yep, that would be the next one in the line. And I can draw my line. It's got a negative slope, hence it is going downhill. Got it? Let's try the last one. All right, excuse me. The last one has -3, -2, -1, 0, 1, 2, 3. Okay, this side's all going by 1, plus 1, right? So that's pretty good. 8 to get to 3. Oh, well, that would have been -5. 3 to get to 0 is -3. Do we have a pattern going here? Next one would be -1. And then 1 to get to 0, we got +1. This is not happening. So this is +3, this is +5. Interesting. Okay. Try graphing those points while I go let Max out, and I'll be right back. Okay, so this is not going to be linear. This is not linear. Right? But what's it going to be? Let's take a look. Okay, so if I plot these points, -3 and up to 8, of course 8's off the table, -2, 3. So -2, 1, 2, 3. -1, 0, right there. 0, -1, so that's down here. 2, 3. Sorry, 1, 0, 1, 0 first. Now 2, up 3 on 2, 3. Yep, we're matching. So we have a nice parabola here. Okay, so technically this is a quadratic. And that would be the parabola here. Okay, the actual equation is y equals x squared minus 1. So let's look at this. If we squared 2, 2 squared would be 4, minus 1 makes 3. 1 squared is 1, minus 1 makes 0. 0 squared minus 1 makes -1, and so on. So that's how this equation works, okay? You would not have to recognize that in 8th grade. But they're just showing you the differences of how the tables will have a consistent pattern, therefore it's linear. A consistent pattern in both the x and y, therefore it's linear. Okay? Let's try the back. Again, sample test questions. Example 2. Jack and Manny each have a savings account. The graph represents Jack's account. Manny deposited $500 and withdrew 20 each even-numbered day for 30 days. Compare the two functions. So we've got Jack's account is over here. Okay, this is called a step graph. And I'll explain that in a second, a step function. Where, again, you might recognize, it might pop up on the 8th grade test, but just so you know, why is it called steps? It looks like it's steps, all right? And I'll explain the open circles and such. So on this side, it says here, let's figure out Manny's deposit. So we're going to say let n represent the even, so n equal the even number days, right? Because Manny deposited, withdrew on even number days for 30 days, right? And y can be the money in the account, right? So let's figure out our equation. Y would be, so Manny deposited $500. He starts out with $500, withdraws 20 for each even number day. So I'm going to say minus 20 times n being that even numbers day. So there's his equation. Okay? Whereas over here, this is called a step function. Jack's savings account. This is interesting. This is a guaranteed linear function right here, whereas his, this, so we can call this a linear function, meaning it would graph as a line starting at 500 but going down at a rate of 20 every even number of days. All right. Whereas this one over here, they call it a step function because it starts, so Jack's savings account starts, and the dark circle says he has $100. It looks like 6 days, in 6 days, it went to $200 is in the account, even $200, right? At $200, it went over to, in 12 days, at the 12th day of this whole time period,
he now somehow, since it went down to 150, he withdrew $50. So for a period of what do we got? 3 days, it was at 150. Then it went back up to, he obviously put money in, it's up to 250, stayed at 250 until day 20 or so, and see how it keeps going and keeps going. It's a step function, okay? This is called a step function. It looks like steps, and that's why it's called a step function. That's the difference. Linear function, step function, okay? Take a look at this one. Which function has a greater rate of change? So we're looking for the slopes. All right, we need to find the slopes and compare slopes. So remember, changing y, we're changing x, and so on. This one you do from the table. This one you got to rearrange the equation. Try it for yourself. Okay, so which function has a greater range of change? So let's look. The x's is going 1, 2, 3, 4. It's going by 1. That's perfect. And the y's is going by, what do we got? By plus 3. So if I write the change in y over the change in x. Change in y is by 3 and 1, so technically here m equals 3. Can we figure out, if I went 1 unit back, remember we want to figure out what the 0 is. So 0 would be here, right? 0, 1, 2, 3, 4, so on. So if I have to go backwards, what's in front of that? A 2. Right? Take away 3 from the 5, you get 2. So that's your b. So your b here is 2. So my equation, since this is linear, is y equals, slope is 3x plus 2. And so my rate of change is 3. Increases by 3, so positive 3. Whereas this one, I'm going to move this over. 3y minus 6 equals 12x. I want to get it in the y form. I want to get y alone. So I'm going to move the 6 to the other side. Move 6 over here. So I get 3y equals 12x plus 6. Y is still not alone. Must divide by 3, divide by 3, divide by 3. And I get y equals 4x plus 2. Rate of change is 4. So this is the greater, I cannot write, greater rate of change. We good? Try the next one. Okay, so this one bounces a little bit, but we won't. It could. If you just skip the 2, and skip the 5. Let's see how this works. So we know 1 to get to 3, you go plus 2. Okay, and then 3 to get to, this is like, okay, this was plus the 1, and then 4 is a plus 2. On the bottom, 5 to get to 13. 5 to get to 13 is 8, right? And then 13 to get to 17 is plus 4. And then 17 to get to 25 is plus 8. So to be honest, guys, it's constant. The pattern is constant. So this is true. So if we were to compare 2 points, let's take these last 2 points, and we did the formula for y2 minus y1 over x2 minus x1. Okay, let's do that. y2 minus y1 would be 25 minus 17 all over 6 minus 4. So we get 8 on top over 2, so the slope is 4. So our m, my rate of change here, is 4. Okay? Now if we go backwards to get that 0 again, we want to figure out what is 0. 0 would go there. And to get from here back, since if we keep this pattern going, it would have to be take 4 away. So therefore, it has to be 1. Do you see where if I would take 4 away from here? Because we did 4, 8, 4, 8. It has to continue. So I know my B is 1. My equation then is y equals 4x plus 1. Okay? Let's do this one. Can't figure it out here the way it is. We have to rearrange the equation. 2y minus 2 equals 4x. I need to get y alone. So I start moving everything. Plus 2, plus 2. Remember, they're not like terms. So I get 2y equals 4x plus 2. I just slide the 2 up. Divide everything by 2, by 2, by 2. Y equals 2x plus 1. Greater rate of change over here. Greater rate of change because of the 4x. Make sense? Not so hard. Same stuff over and over again. Okay, so let's take a look at this next one. Order the stocks from the least to greatest rate of price increase. So price increase would be the rate of change, okay? So let's take a look at the change. We want to look at the change in Y over the change in X. These are 3 different companies. This company has it in a table or chart form, so we got to kind of figure this out. Change in X is by 1. Change in Y. So from $21, then down to $16.50, then down to $12, then down to $7.50, then down to $3. What did it decrease by? Minusing $4.50. So the change here is $4.50. Oh, we have the B. So the equation for this one we can write out is negative 450x, right, plus 21. So the stock or whatever, stock prices started at $21, and then what did it keep doing? Decreasing by $4.50. Yeah, that would be bad if you owned that stock. Okay, Beta Company, the starting price of 54 decreases weekly by 250. Okay, so the equation for this guy is the starting price is 54, but decreases by 250 weekly. So I'm assuming that, oh yeah, that's by week too. So negative 250x, and what did it start at? At positive 54, right? And the delta, we can't figure this out the way this is written. We want to get, I think we want to get the D all the way along. We want to know the dollars all the way along, okay? So if we want to solve for D, I got to move things around here. So I'm going to put minus 7w under it, minus 7w over on this side. So I get negative 2d equals negative 7w plus 54. Now I'm dividing by negative 2. Divide by negative 2, divide by negative 2. I get d equals negative divided by negative is going to be positive, and 7 divided by 2 is 350. So 350 per week, and 54 divided by 2 was, negative, because that's positive, negative 27. So, order the stocks from the least to the greatest rate of price increase. So, price increase, from the least, the smallest price increase will be the alpha, the smallest, because they have the biggest negative number, right? So alpha has the biggest negative number, so that is the smallest. Then we have beta, because then it's negative 250. And finally, this guy is at least doing a positive delta, or DEL. Delta. Good? Again, not so hard, right? And now your homework. Okay? On your own, try it, and I will put up the answers next. Okay, first page of the homework 14. Take a look. You have to find the slopes on each. A little bit of work. Okay, to the bottom. And there they go. Marley is the loudmouth. Okay, so homework 14. I don't know if I filmed this or not. So which was the greater rate of change in each one? So we're going to take a look. Take a look. Definitely would use a calculator on this. Remember on the bottom here, you're going to divide by 1/8, which really means you're multiplying by each one of these by 8 over 1, which comes out easy. Really simplifies nicely. Anyway, so you're looking for greater slopes. Greater slope was this one. The greater slope was there. The greater slope was here. Okay. And we did this already. The alpha, beta, delta. Did that one. And the last page. Looking at the two tables to see if they're linear or not. Okay, this one is linear because it has a constant pattern. On the x's is by 3, the y's by -2, so the change in y over the change in x is -2/3. You have your b, your equation is y equals -2/3 x plus 3. This one would actually be quadratic the way this turns. This was not linear, so that's as far as you can go. Okay, now down here is a very typical test question comparing car rentals. This car rental Avis does it in a table, so you had to find the rate of change, and it comes out to be $30 per day. Okay, you can see it right here. 130 minus 100 would be 30. Divide by 3 minus 2 is 1, so you get 30. So and I did it with this one too, the rate of change here, so you could see it. So it's definitely $30 per day. That's the rate of change. Enterprise tells you it. The cost is $30 plus $25 per day. The rate of change would be $25 per day. The last one, you have to manipulate the equation, change it, solving for the cost. You want C alone. So move the 7D over first, then divide everything by -0.25, and the cost comes out to be $28 per day. Order the car deal. It's from the least to the greatest based on their rate of change. I almost forgot that. So based on their rate of change from least to greatest would be Enterprises first. Enterprise, comma, then
Hertz, and the last Avis by rate of change, 25, 28, 30. Okay, and the last page, the back one, is just solving two equations, which this one pretty easy. Distribute this one, because it had a fraction, I multiplied by a common denominator of 9 in every part, canceled out, and gotten pretty straightforward. It's 18. So second packet done.